Yes, you can use sheathed cable. According to the National Electrical Code, you can use either conduit or sheathed cable for wiring between the main disconnect and the house main. The NEC allows for the use of Type SE cable, which is a sheathed cable commonly used for service entrances. Firstly, size the cable properly. Use a cable that is rated for the amperage of the main disconnect. Secondly, protect the cable from damage. Install the cable where it will not be subject to physical damage or exposure to moisture. Thirdly, secure the cable. Use approved cable clamps or straps to secure the cable along its run. Fourthly, provide drip loops. Install drip loops at the points where the cable enters and exits the house to prevent water from entering the electrical system. Fifthly, terminate the cable properly. Use approved connectors to terminate the cable at the main disconnect in the house main. You can route the cable down the outside of the house and then back up through the wall. Ensure that the cable is securely fastened along its run and protected from potential damage. If the sheathed cable is exposed to sunlight, consider using a cable with UV protection to prevent degradation over time. If the cable is routed through a wall or ceiling, use an approved fire-rated cable or install it in a metal conduit for added protection. Always follow local codes and consult with a qualified electrician to ensure compliance and safety. When selecting the appropriate size of the sheathed cable, refer to the National Electrical Code tables for ampacity ratings based on conductor type and insulation temperature rating. Ensure that the cable's ampacity is equal to or greater than the overcurrent protection device, such as a circuit breaker or fuse protecting the circuit. It is crucial to consider voltage drop when determining the conductor size, especially for longer runs. Excessive voltage drop can lead to inefficient operation of electrical equipment and potential overheating. Consult with a qualified electrician or use voltage drop calculation tools to ensure that the selected cable size minimizes voltage drop to acceptable levels. When protecting the cable from physical damage, consider using conduit or other protective measures in areas where the cable is likely to be exposed to impact, abrasion, or other hazards. For example, if the cable runs along a wall in a high-traffic area, it may be necessary to install a metal or plastic conduit to shield it from damage. If the cable is buried underground, ensure that it is installed at the proper depth and protected from rocks, roots, and other potential hazards. Use approved cable clamps or straps to secure the cable along its run, ensuring that it is properly supported and protected from strain. The spacing between supports should comply with the National Electrical Code requirements and the cable manufacturer's recommendations. Avoid over-tightening the clamps or straps, as this can damage the cable insulation and reduce its lifespan. When installing drip loops at the points where the cable enters and exits the house, ensure that the loops are large enough to prevent water from running along the cable and into the electrical system. The drip loop should be positioned below the entry and exit points, allowing water to drip off the cable before it reaches the building. Use approved connectors to terminate the cable at the main disconnect in the house main. Ensure that the connectors are properly sized for the cable and that they provide a secure and reliable connection. Follow the manufacturer's instructions for installing the connectors and tightening the terminals. Avoid over-tightening the terminals, as this can damage the connectors and lead to loose connections. When routing the cable, avoid sharp bends and kinks, as these can damage the cable insulation and reduce its ampacity. The minimum bending radius for the cable should comply with the National Electrical Code requirements and the cable manufacturer's recommendations. Ensure that the cable is not exposed to excessive heat or cold, as this can also damage the insulation. If the cable is routed through a wall or ceiling, use an approved fire-rated cable or install it in a metal conduit for added protection. Fire-rated cables are designed to resist the spread of fire and smoke, providing additional protection for the building and its occupants. Metal conduit can also help to contain a fire and prevent it from spreading to other areas. Always follow local codes and consult with a qualified electrician to ensure compliance and safety. Local codes may have additional requirements for electrical installations, such as specific grounding requirements or restrictions on the types of cables that can be used. A qualified electrician can ensure that the installation complies with all applicable codes and regulations, and that it is safe for the building and its occupants. Remember to de-energize the circuit before working on any electrical components. This will help to prevent electrical shock and other injuries. Use a voltage tester to verify that the circuit is de-energized before starting work. Wear appropriate personal protective equipment such as safety glasses and gloves when working on electrical systems. This will help to protect you from potential hazards such as arc flash and electrical shock. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to do the work safely. Before starting any electrical work, obtain the necessary permits from your local building department. This will ensure that the work is inspected and approved, and that it complies with all applicable codes and regulations. Keep a copy of the National Electrical Code on hand for reference. The National Electrical Code is a comprehensive set of standards for electrical installations, and it is important to be familiar with its requirements. Consult with a qualified electrical inspector to ensure that your electrical work is done safely and correctly. Electrical inspectors are trained to identify potential hazards and to ensure that electrical installations comply with all applicable codes and regulations. When selecting electrical equipment, choose products that are listed by a recognized testing laboratory such as Underwriters Laboratories or Intertech. Listed products have been tested and certified to meet safety standards, and they are more likely to perform safely and reliably. Follow the manufacturer's instructions for installing and using electrical equipment. This will help to ensure that the equipment is installed correctly and that it operates safely. Inspect electrical equipment regularly for signs of damage or wear. Replace any damaged or worn equipment promptly to prevent potential hazards. Keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause it to overheat or malfunction. Avoid overloading electrical circuits. Overloading circuits can cause them to overheat and potentially start a fire. Use extension cords sparingly and avoid plugging multiple appliances into a single outlet. Be aware of the potential hazards of electricity and take precautions to protect yourself and others from electrical shock and other injuries. Electricity is a powerful force, and it is important to treat it with respect. In addition to the above considerations, it is also important to be aware of the potential for corrosion when installing electrical cables in damp or corrosive environments. If the cable is exposed to moisture, salt spray, or other corrosive substances, it may be necessary to use a cable with a corrosion-resistant jacket or to install the cable in a conduit made of corrosion-resistant materials. The National Electrical Code provides specific requirements for electrical installations in corrosive environments, and it is important to comply with these requirements to ensure the safety and reliability of the electrical system. When selecting a cable for use in a corrosive environment, consider the type of corrosive substance that the cable will be exposed to and choose a cable with a jacket that is resistant to that substance. For example, if the cable will be exposed to salt spray, it may be necessary to use a cable with a jacket made of polyvinyl chloride or other corrosion-resistant materials. In addition to selecting the appropriate cable, it is also important to properly seal all connections and terminations to prevent moisture from entering the electrical system. Use approved connectors and sealing compounds to ensure that the connections are watertight and airtight. Inspect the connections regularly for signs of corrosion and repair any damage promptly. When installing electrical cables in damp or wet locations, it is also important to provide adequate drainage to prevent water from accumulating around the cables. Install drain holes in conduits and junction boxes to allow water to drain away from the electrical system. Ensure that the drain holes are not blocked by debris or other obstructions. Consider using a ground fault circuit interrupter, or GFCI, to protect circuits that are located in damp or wet locations. GFCIs are designed to detect ground faults and to interrupt the circuit quickly, preventing electrical shock. GFCIs are required by the National Electrical Code in certain locations, such as bathrooms, kitchens, and outdoor areas. In addition to the above considerations, it is also important to be aware of the potential for electromagnetic interference, or EMI, when installing electrical cables. EMI can be caused by electrical noise from other equipment or by external sources, such as radio transmitters. EMI can interfere with the operation of electronic devices and can even damage electrical equipment. To minimize the potential for EMI, it is important to keep electrical cables away from other sources of EMI, such as transformers, motors, and electronic equipment. Use shielded cables to reduce the amount of EMI that is radiated from the cables. Ground the shields properly to provide a path for the EMI to flow to ground. Install filters on electrical circuits to block EMI from entering the system. In addition to the above considerations, it is also important to be aware of the potential for harmonics when installing electrical cables. Harmonics are distortions in the electrical waveform that can be caused by nonlinear loads, such as electronic equipment and adjustable speed drives. Harmonics can cause a number of problems, including overheating of electrical equipment, increased energy consumption, and interference with other electrical devices. To minimize the potential for harmonics, it is important to use equipment that is designed to minimize harmonic distortion. Install filters on electrical circuits to reduce the amount of harmonics that are present in the system. Oversize electrical conductors to account for the increased current that is caused by harmonics. In addition to the above considerations, it is also important to be aware of the potential for voltage sags and swells when installing electrical cables. Voltage sags and swells are temporary fluctuations in the voltage that can be caused by a variety of factors such as lightning strikes, switching of large loads, and problems with the power grid. Voltage sags and swells can damage electrical equipment and can cause malfunctions in electronic devices. To protect electrical equipment from voltage sags and swells, it is important to use surge suppressors and voltage regulators. Surge suppressors are designed to protect equipment from voltage spikes, while voltage regulators are designed to maintain a constant voltage level. Install uninterruptible power supplies, or UPSs, on critical equipment to provide backup power in the event of a power outage. In addition to the above considerations, it is also important to be aware of the potential for arc flash when working on electrical systems. Arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. Arc flash can cause serious burns, injuries, and even death. To protect yourself from arc flash, it is important to wear appropriate personal protective equipment such as arc-rated clothing, gloves, and face shields. To energize the electrical system before working on it whenever possible. Use insulated tools to prevent electrical shock. Maintain a safe working distance from energized equipment. Follow all safety procedures to minimize the risk of arc flash. In addition to the above considerations, it is also important to be aware of the potential for static electricity when working on electrical systems. Static electricity can build up on clothing and other materials and can discharge when you touch an electrical component. Static electricity can damage sensitive electronic components. To prevent static electricity from damaging electrical components, it is important to wear static dissipative clothing and shoes. Use anti-static mats and wrist straps to ground yourself before working on electrical equipment. Handle electronic components carefully and avoid touching the pins or leads. In addition to the above considerations, it is also important to be aware of the potential for rodents and other pests to damage electrical cables. Rodents and other pests can chew on electrical cables, causing damage to the insulation and conductors. This can lead to electrical shorts, fires, and other hazards. To protect electrical cables from rodents and other pests, it is important to seal all openings in the building to prevent them from entering. Use rodent-resistant cables or conduits to protect the cables from chewing. Install rodent guards on electrical equipment to prevent them from accessing the equipment. Inspect electrical cables regularly for signs of damage from rodents or other pests. Remember to consult the National Electrical Code, local codes, and a qualified electrician for detailed guidance and specific requirements related to your electrical installation. These resources provide the most accurate and up-to-date information to ensure safety and compliance.